And as always, we want to put a Green Home Institute membership spotlight and a big congratulations to our member, Sanderson Sustainable Design, for achieving 2024 Best of House service. Now, Shannon focuses on zero energy passive house plus building science solutions. They help teams and clients by listing priorities, goals, and sharing proven, affordable, beautiful, low carbon designs. You can check them out over at House. And this is who Green Home Institute members are. This is what Green Home Institute members do. And so can you. Go to our website, greenhomeinstitute.org, become a member, and learn more today. And before we get started, a huge thanks to our gold level sponsor, Build Equinox, featuring the Serve 2. This device is an all-in-one heating, cooling, ventilation, filtration, and some humidity control system. Smart ventilation energy recovery is the future. It detects poor air quality in a home or school, and then ramps up to remove it as needed, but then runs very low, saving energy and carbon when air quality is good. The Serve 2 features energy recovery ventilators, so fresh air brought in is not wasted, and a built-in heat pump to ensure incoming air is not too hot or cold. The Serve 1000 is being deployed across schools now to help keep students healthy and safe and decarbonize our heating and cooling. Check out buildequinox.com today. All right, well, welcome everyone to Reducing Carbon with Environmental Product Declarations, or EPDs. This course is brought to you by the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. We're a small but mighty staff. I am the education manager here. My name is Brett Little, and I will be your moderator today. This course is approved for multiple continuing education units, including a new one we have that I forgot the logo on, but our friends over at Sarah are now part of our education family, as well as the Certified Green Home Professional Designation in Materials. AIA Health, Welfare, and Safety may make it applicable to the state-based design or contractor license. Check out your Certified Passive House Consultant code sent to you after this session. Now, environmental product declarations are important because we talk and have talked a lot about upfront carbon, or operational carbon, if you will, and that's becoming more and more important about reducing our carbon during our construction practices. EPDs, or otherwise known as EPDs, fit into the overall scheme of green building, because operational carbon is getting easier and easier to reduce as we look at zero energy goals, net zero operations, and reducing that power consumed by heating, cooling, lighting, and other appliances and mechanical systems in our home. And now we're turning our attention to the actual construction practices and the materials themselves. And so in the grander scheme of green attributes, the EPD certificate plays a very small but important role on ensuring that reduced embodied carbon. Now, in LEED Commercial, this is more of an accepted practice, as it's built right into the materials and resources section of the rating system, as you can see on the top there. In LEED for Homes, this is still an innovative credit and does not show up on the formal checklist, so you have to look for it under innovation. Now, will it be adopted in LEED V5? Should it be? You can have your voice to determine that. Here are some of the basic details of how the EPD fits into LEED and what is required. These are both industry-wide generic EPDs and product-specific EPDs, and we're going to discuss kind of the overview or the higher levels of both of these here in this discussion today. So now, whether you're planning to do a LEED project or some other green building certification, or you just want to make more informed decisions on your new construction or major renovation projects, I am super excited to introduce our speakers today to help guide you through this. So a big welcome to Chris and Anik. And first, I'll hand it off to you, Anik, to take it away.
Hi, Ron. So thanks for the invitation. So my background, I'm a faculty at Michigan State University. I'm an associate professor in civil and environmental engineering. And my area of expertise is the environmental impact of products. So I do a lot of life cycle assessment, and EPDs are built from life cycle assessment studies. So I'll be happy to discuss a bit more about that with you. The other thing about what I do in Michigan, I'm the assistant director for the Industrial Assessment Center. And also we're starting a new program now for training in the building. So it's a building training assessment center to train more students into becoming energy expert and be able to do assessment of building and hopefully build better, greener building in the future.
And then Chris, if you want to quick introduce yourself, you should be able to share now.
Hello, everybody. My name is Chris Erickson. I'm the founder and CEO of a company called Climate Earth. We're probably best known for inventing what are called automated EPDs or EPD generators that allow EPDs to be created in, we like to say, in minutes, not months. We delivered the first of this type of tool back in 2013, so it's been around a while. And we currently have generated over about 60,000 concrete EPDs. We're in other areas, but today I'm going to be focusing on concrete, where our company is currently focused, and where you all, as owners, architects, buyers of residential facilities, have probably the most leverage to reduce embodied carbon. Thanks a lot. Talk to you soon.
Okay, I'm trying to remove the bar and everything. Okay, so I'll start with the first part of the presentation, talking a bit more about the background and how do we make environmental product declarations. So the same as the life cycle assessment methods, those are methods that are defined by standards. So the main standard that is used for environmental product declaration is the ISO 14025, and what it provides is guideline about how we should conduct the environmental product declaration. The EPD quantify the information for the life cycle of a product, and the goal of EPD is really to be able to compare different products on an equivalent basis. So it mostly provide guidelines. So when we produce EPD, we assume the same, we use the same assumption. So kind of taking one step backward, how we do EPD is based on life cycle assessment. So what is life cycle assessment? It's again like another type of standard. It's the 1400 series, and there is like specific substandard that specify if you're doing mostly carbon, which is the theme of this discussion today, how you would do that. So in a life cycle assessment, we need to consider not just the manufacturing of the product, but the full life cycle of a product, from the raw material extraction to processing, manufacturing, and assembly. And finally, like how the product is going to be used will impact its overall impact, for example, in particular, like the lifetime of a product. And then finally, what we do at end of life. So the foundation of all EPD is performing life cycle assessment, but the EPD will specify more information about how to make some assumption about like the raw materials or what needs to be included or excluded, as well as what steps needs to be included in the EPD. So there are EPD for various categories, and how those specific categories are done, it's based on product category rules, or PCR. And again, this is just a kind of a subset of a general method, which is the life cycle assessment, that tells you how we create EPD. So for each different, a little bit hard to see with this resolution on my screen, but for different products, how are you expected to conduct the life cycle assessment? So the step for an EPD, first of all, actually collecting the data would be the first step for doing an LCA. The first step is pretty much usually for an LCA to figure out what would be your goal and your scope. But when you're doing an environmental product declaration, this is already defined by the product category rule. It tells you what needs to be included, what assumption to do, so you don't necessarily need to worry about that. But you still need to collect the data. If you're a manufacturer, you need to and the data, we call it lifecycle inventory normally. So we need to know how much energy, how much water, how much chemicals are used for making your product. And then we translate that into emission or impact using various lifecycle assessment software. So again, like depending on what is the scope of the LCA for the EPD, normally it's called like a cradle to gate. So we only consider the raw material all the way to making the finished product, not the use phase. Then that's what is going to be submitted for approval. So the company interested in getting an EPD for a product needs to submit a report for verification. And the third-party verification can be either like expert in that particular product or expert in LCA methods that verify mostly that all the methods follow the ISO standard. So the third-party verification, also how it's done, that's another thing that is usually specified in the EPD or the PCR rules, and who can be accredited or who can do like the third-party verification. And finally, the EPD is published. So those EPD have a limited lifetime. So, and this is to ensure that like products evolve, how we're manufacturing them will change over time. So we need to regularly update those EPD to reflect change in product production. In particular, we might not change how the product itself is made in terms of like the energy demand or so on, but things like where the material is coming from or the energy required for making it might change over time. So, and for that reason, it needs to be updated. So there are EPD for a lot of different type of product. I know today we're most interested in the building and construction industry. And this is a big area where there is actually EPD because you have other standard, as Brett mentioned, from the league standard that ask for EPD product. So it is a big push towards getting more EPD when it is required for an external certification, but you can have EPD for vehicle, equipment, infrastructure, buildings, paper and plastic, textile, and so on. The other thing I forgot to mention, like why is the data important in the data collection, is because EPD will change based on location. So Europe has been really upfront into requiring a lot of EPD for a lot of products. So they've been around for longer than they've been in the US or North America. And if you take an EPD for the same product, but based on European condition, the carbon footprint might be really different. So we need to make sure that we're using EPD that are representative of the condition or where we're going to use the product. So in the construction industry, again, as I said, there is like the general 1400 standard, but then all of those different industry will have their own standard that says how should we conduct this EPD. So for construction, infrastructure, a lot of the standards are the ISO or the EN 15804. And you should just see some example of that. For example, for steel, smog reducing roofing granules, I'm not sure I know what that is. And so on for cement. I know like the next speaker is going to talk more about concrete and the EPD is making, and also a lot about like asphalt. So this is becoming more and more common that EPDs are required or encouraged by state or other agency as part of their requirement for new project. So in the building and construction, again, like that's a little bit outside of the home area that you're interested in, but that's an area where I've been doing a lot of work on the sustainable pavement program, because a lot of my research is looking at how to make new materials in roads. So we did a lot of work on like scrap tires for road pavement. So, and part of that, if you want to have a new product and you want to compare it with the existing one of the main steps is to create a new EPD. So your EPD, for example, for pavement, a lot of time is about like what materials you're putting in, how do you transport it to get to like the production plant, and that's mostly for kind of the design and the procurement of the project. Like how it is how the road is constructed, used, and the maintenance. That's another stage that is not necessarily included if you're doing these two steps of the EPD. The sustainable assessment asset management, though, can include these next step, which is more about like how the road is going to be used, the plan, maintenance, and rehabilitation, and also how do you plan for recycling the product at the end of life. So even though like it's not super common for EPD to plan for end of life, newer criteria or new methods are trying to extend this part of the disclosure, so it helps people make a better decision in the design phase. So some states have engaged a little bit more into those EPD requirements. So the states in green have sustainable pavement program, and the Buy Clean Acts require the use of EPD in different states, California, Colorado, and Oregon. Those are pretty recent. This is all things that happened in less than last 10 years. And there's more and more local agency and federal also agency that are looking into more how can we use EPD in pavement material and road construction. There are existing pavement material for PCR. So for example, if you're doing asphalt mixture, concrete, construction aggregate, Portland mortar, and slag cement, you can see that another thing I haven't necessarily mentioned so much yet is what we call like a program operator or an organization that is in start of like preparing those EPD. And as you can see, NSF International is actually one of the agency that does a lot of those EPD. And I've worked on EPD, like new rules for EPD for different product, in particular solar modules, which is a big area I work in, and also like other electronic products. And those takes a really long time to establish. For EPD for road materials, again, what is specified in the process, it's not only carbon footprint. Carbon footprint is only one of the category. I would say it's usually the easiest to calculate, but normally the EPD also requires other types of impact categories. So this is an example where you would get the global warming potential, ozone depletion, eutrophication, acidification, and photochemical ozone creation potential. So that's another part of like what is specified by the product category rule is what kind of impact needs to be included in the environmental product declaration. So it's good to reduce the carbon footprint, but also another advantage of doing life cycle assessment in general is to make sure that the product we're creating, or if we're developing an alternative to something that is polluting, is not creating new impacts. So that's why the EPD normally are not restricted to one type of environmental impact, because one product might reduce a lot of carbon, but if it creates like toxicity, it's not necessarily much better. So we want to be able to compare products more on a fair basis that and include various type of impacts. So how is this included in the U.S. Green Building Council? So Brett mentioned the LEED building and the active EPD requirement from the building product disclosure and optimization for the environmental product declaration. So I'll give a little bit more details about how this is done. So this is, I think, the same slide you showed a bit earlier about how this is included. So there is actually two options. It's not necessarily doing option 1 or option 2. You can get 2 points if you're doing both together, but it obviously requires a lot more work to do both. So you need to include, to get the full point, like 20 different products for at least 5 different manufacturers. And I'll get to that a little bit later, but that gets a bit complicated because usually to do EPD, it's pretty time consuming and can get a bit expensive. So a lot of time you have a lot of EPDs from one large manufacturer, but not necessarily from a lot of smaller manufacturers, because they just don't necessarily have the ability for doing this kind of assessment. So in order of priority, you can get product that have critically reviewed full life cycle assessment that are conformed to ISO 14044. So as I said before, like a full LCA is more time consuming because it needs to require also like the end of life. So some products do have a full life cycle assessment, but a lot of the EPD were created so it would be simpler and more achievable for more companies to get a product declaration. So I would say the second and third is more common for product in the construction industry, and that's where I would say a lot of the push and support is from government agency to get more product to be certified under EPD and not necessarily full LCA, because it's a lot more work and more time to include the use phase and the end of life. And in terms of like what a lot of people are doing, if you're in the construction industry, you don't necessarily know how the building is going to be used or and so on. So it's not necessarily in the design phase. So the second option is to use EPD that conform to the other ISO standard that are only for EPD. And those, as mentioned here, have a cradle to gate scope. So cradle to gate means from raw material up to the point the product is manufactured. So I don't know, like a door is manufactured and then that's it. So no matter how you're using the product or where you're going to install it, the EPD is not going to change. So you have two different types of EPD. You can have a generic EPD that has gone through a third-party certification and external verification. But if you do this kind of product, then you only get half the credit for doing it. The other type of type 3 EPD would be product-specific information that add all the certification and the external verification, and then you will get all credit for that option. So having the product specific is always preferred to the generic industry-wide EPD, but this is done so you're not discouraging as much product that don't necessarily have an EPD on the book yet or approved, because those take some time, in particular getting the external verification and approval, but it is required to get the credit. The third option is to have a product that have been approved that is under the USGBC approved program, and those are kind of a subset of category of how to conduct EPD. So I just put some of the approved third-party certifications. So again, based on what I said before, a lot of the standard are based from the NSF standard organization. And they are mostly designed per type of product. So, and again, it provides the NSF guidelines, provide information about like how to conduct the environmental product declaration study. And they are per category of products. So this is like a method that is only for floor covering. If you would have like furniture, that would be a little bit different. And for all of those third-party certification, though, the USGBC doesn't give you full credit for using those, depending on like the cost of the product versus the total product cost of the project. You get different level of credit for that. So again, like specific industries, specific their own method for conducting LCA and EPD, and usually how this is done is by having expert in that area creating the rules, because they know more what is the average way of doing it, how most people do it, and what should be included or not. And it's usually a consensus process there. So the other option, like the first option, is really going product by product, and you need to include a certain number of product on your total construction. The second option is really to help to encourage the selection of products that are better than the average. So in the first option, you get credit for just using EPD. It doesn't matter if you're choosing the product that has high carbon footprint, for example. What matters is just that you use a product that have an EPD. So you may wonder, like, why do companies bother to get like an EPD if they are not doing better than the average? It's actually in terms of like sustainability, it's actually a good thing, because a lot of time before you go through the life cycle assessment or the EPD, you don't really know what is the impact of your product. So as a company, usually you get well, it's good for a company to do an EPD because at least if you're using that product, you're going to get credit for LEED, but also it's best practice because when you've done it once, most of the time those companies will go back and identify ways of reducing their impact. And that's also another motivation for resubmitting a new EPD or conducting new lifecycle assessment that reflect improvement in the process. So option 2, as I said before, normally what is encouraged is to do like option 1 and option 2. Option 1 really favor if you're just using EPD in your construction. Option 2 is where you get credit for selection of EPDs that are lower than the average. So, and how those criteria need to be fit. Again, for EPD, normally it's not, and in particular for LEED, it's not just about carbon, it's all different type of impact categories. And for option 2, they specify which impact categories you need to look into. There is CO2, but there's also ozone depletion, acidification, eutrophication, tropospheric ozone, and depletion of non-renewable energy resource. So what the criteria kind of say is you need to use product that comply with one of the criteria below for 50% by cost of the total value of currently installed products in the project. So it's not a single product, it's the cumulative value of the product you choose needs to have a product that have an impact reduction below the industry average for at least 3 of the following categories, valued at 100% of the cost per credit achievement calculation. So I'm going to reread this sentence. It gets a bit complicated pretty quickly, but pretty much you cannot choose a product that just has a lower carbon footprint. And if it increase acidification and eutrophication, then it wouldn't fit the criteria. So the goal is to encourage product that I would say are more sustainable because they have a reduction in multiple impact categories. And similar to the previous thing, there is like third-party certified product, but also other programs that are approved by the USGBC there. And there is more sub nuance about like how you apply this credit. So there's always in LEED a lot of support for products that are manufactured and purchased close to where you're doing the construction. And so on in terms of how you do that and the limit on how you do this calculation. But overall, like kind of the take-home message for that is LEED is giving credit for both using product that have an EPD, an existing EPD, but you get even more credit if you select EPDs that are better than the average for at least 3 impact categories based on LCA calculation. So I'm not going to spend a lot more time on that since I know we'll talk about concrete in a few minutes a little bit more, but there is specific category for concrete. This is showing an example of how like the product, the PCR will define the system boundary for you, so you don't have to do that by yourself. And also, so manufacturers assume the same assumption. So it specifies what you should include in the raw material supply, the transport to and then the manufacturing in terms of the input, what all the other materials you're using, if you're including water, but also like the waste that needs to be processed from your manufacturing. And then this is specific for that industry, I guess. So there you get like 30% total fleet energy transit mixed plants only. I have no idea what that is, but I would think if I was in the concrete industry, I would know that area a lot more. So this is comparing like different products. I don't know why it looks like that, but you can see that all products don't have the same impact in different categories, but the EPD don't just report the carbon, it reports multiple output. And then as a result that you can figure out what would be the total impact of your product. Similar, the wood industry, there's a lot of interest now with more carbon neutral building, and using wood for reducing carbon emission is I would say a pretty hot topic right now because you can sequester a large amount of carbon dioxide by using wood products. So there's been a lot of interest in developing EPD for wood products. But again, this gets tricky, and the LEED standard recognized that you might be able to reduce the carbon emission because you're using wood instead of like steel or other non-renewable source. But depending on how this product is produced, you might increase other environmental impact that are not necessarily good overall. So again, the PCR for wood, they include like what stage, the resource extraction, how not just the plant grows and how much carbon is captured is important, like how you manage that forest and all the logging transformation of the product all the way to the finished product needs to be specified, but also data needs to be collected and verified that you're not underestimating your emission to make it look better than it is. So that's the main goal of the PCR program. So again, that's just an example of the different stage of a product and what kind of impact indicator you would look at. So from like the forestry operation, the wood residue, and the final product production. So usually for wood products, not really surprising, the final production has more impact than the forestry or growing the tree, but we need to include all of those stages in the EPD there. So one of the things I want to finish my presentation on is it is great. There is a lot of like EPD available. It's growing really quickly in US because of kind of more support and requirement from other standard. But sometimes one of the concerns is just that we cannot find LCA or EPD for some of the construction products or things we want to include in your building. And the main reason is because conducting a full LCA is very complex and it requires usually expertise that is beyond what the manufacturer usually do. So, and the investment in doing, if you're a big company, a lot of those big companies usually have internal LCA experts, so they are able to do most of the work in a house, like collect all the data. And then the only thing you need to do is get external certification. So this is kind of less expensive per product, but if you're a small company or a small manufacturer, you don't have the LCA expertise to do it. So normally you need to work with an external consultant, or my group do, actually I do LCA or I do EPD for some product, or I help a company that want to get started and just don't know what to do. But this is an area that is growing really quickly, and there's just not enough people that are good at doing LCA for like creating EPD for all the products that exist. So I would say that's kind of a main drawback, and that kind of limit what you can use in your product manufacturing. The other thing is, as I said, LCA and EPD, they need to be updated when product change. And if you change your manufacturing location or your kind of your recipe, then your product declaration is not valid anymore. So it doesn't necessarily encourage manufacturers to improve because they want their product to keep being certified. So they usually are a little bit delayed with what we're getting, and it's not. But it is getting better in updating rapidly the EPD to reflect change in manufacturing. And I actually had already said that, but most LC and EPD are not done internally. A lot of time they are done by external consultant. There's more and more companies that do LCA consulting. Actually, a lot of my students, that's what they want to do when they graduate. They want to be one of those companies and do a lot of different products for different companies. So it's always changing. But those LC consulting firms, they usually specialize in a specific industry. So you would have a consultant that are expert in building materials versus like what I do. I do a lot of like energy or solar product. That would be a different company that do a lot of those. So there just needs to be more people that are able of doing LCA and EPD in order for having access to all this environmental product declaration that would help design house or building that have lower environmental impact. And thank you for listening. And I know we're not going to take questions right away, but I'm looking forward for your question later. I just want to thank quickly my postdoc, Angela Farina, because she prepared most of that work. She's the one that does a lot of the EPD and pavement research. And again, that's a really active area of research in construction there. Thank you.
Okay. And I think you made it clear from a construction standpoint, definitely option one made the most sense, given that you're not looking at the full life cycle, you're kind of turning it over during construction. I was just trying to understand better whether you were recommending industry-wide versus product-specific type in the construction industry. I couldn't quite pick up which one of those was really the recommendation from a architectural specification standpoint.
I think it's better to get like the product specific,
Okay.
but like all the product specific don't exist. So that's why we kind of sometimes you have to go there, because it's not all
Yeah.
manufacturers are able, if they have a novel way of making like a, mostly for new product, they just a lot of time it just takes too much time to get the EPD done, that if you want to sell it now, you don't have it. So that's when
Yeah.
you would use kind of the industry average. And
Right.
then later you can switch to the, if there's benefit to the other one, people will switch to the product specific.
Okay. I just wanted to clarify that. So thank you
Okay,
for
hopefully that's more clear now.
It is, yeah,
If-
yeah. I think it was clear. I just wanted to make sure I heard it right. So, well, I'm gonna just real quick an observation I made that I really appreciate, especially considering lead option 2, and I'm glad you went over that multi-attribute optimization, because it really makes me think about the operational energy world we live in still. And there's a lot of comparisons, and by that I mean I think of, we talk a lot about reducing our energy, right? And we so often fail to forget the health of the people living in the home and where the products are coming from. And so we always go straight forward to that operational number to get that carbon down. And what I like about this attribute, and you brought this up, is that it's not just about carbon emissions within products. There's also these other attributes that impact the health of the environment. And so I look at those two just in a way that I see connecting the dots between those, like the people who are very focused on energy and carbon reduction and forget everything else. And so I like that that's in there, and I appreciate you highlighting that. So thank you. So
okay, thanks.
and Chris, I will turn it over to you now. So please go forward.
So I'm going to be talking about, I guess, what I'd call a practical matter of, how do I obtain EPDs? If I want to reduce the embodied carbon of my project, and then how do I know how much carbon has actually been reduced? And to do that, I'm going to focus on concrete, and I'll talk about why in a minute. And then at the end, I'll talk about how do you go find a concrete producer that has these EPDs. And in between, I'll be talking some about automation of EPDs and how that's made them more available and more usable today than they were in the past, mostly because of cost and availability. So let's say just a few things about concrete. As a lot of the industry groups like to say, it's the most used material on the planet after water. And that's because it's amazingly flexible. It's a way that humans can make artificial rock. But that rock is really, can make beautiful buildings like this Bernheimer and Levin Betts tiny apartment building. That's also a greenhouse all at once, or you can mold it into gorgeous things like the famous Sydney Opera House. That all said, it's 8% of global warming, so it's got a dark side. However, there's lots of technologies available right now to concrete producers to reduce the carbon of concrete. And in a typical building, and that's excluding what I would call stick-built homes, it's going to be 40 to 60% of the embodied carbon. So it's a convenient place to focus because of the leverage that you can get in reducing the embodied carbon just by focusing on this one material. And I'll be talking, as I said, about the how and why of that. So let's move on. How available are concrete EPDs? I want to address that and why they're available, the technology that makes them available. And then I think you may have noticed that the LEED standard focuses mostly on getting an EPD, except for option 2. If you have an EPD, you get a LEED credit. But what we're seeing is more and more projects are saying, well, a LEED credit is fine, but I want to know how many tons of concrete or pounds of concrete I've reduced by choosing this sustainable material. So it's shifting. We see the world shifting away from, oh, it's good to be green, to what's the number, a very practical shift. And I think that's driven a lot by the Inflation Reduction Act, which was passed last year, where literally hundreds of millions of dollars are going into reducing embodied carbon and measuring that in construction. And so I'm going to go into a little bit of detail on sort of the other side of the equation. I know most of you are involved in projects and are not producers of concrete, but I thought it'd be useful to understand in maybe a slightly different way the process for setting up an EPD generator. EPD generators are the common way for concrete producers to create EPDs now, because concrete, I used to think that concrete was, a bag of stuff you bought at Home Depot, and it's just, sand and rock and some funny powder, and you pour water and it gets hard. But there's actually thousands and thousands of ways to make concrete. So when we go into a company, we do produce a life cycle assessment, just like Anik said. We go in and gather data. We do the life cycle assessment, which is step 2. We create a branded, customized EPD format for them. And then we send that package to a third-party verifier. In the concrete and construction world, it's usually ASTM or the National Ready Mix Concrete Association, who in each of these in turn subcontracts to people like Anik to do that actual verification work to make sure we've done the work properly. But rather than producing a piece of paper at that point that's good for 5 years, we produce a system, a software database, and all the calculations for that database have been pre-verified, all the materials that have gone into it for the particular supplier, and that allows them to generate a type 3, the 1-point version for a lead, anytime at any moment for any mix design. And then included in this, because any brought up the issue that EPDs are hard to update. Well, because now we have all the data in a database, if they make a change to a supplier or a material distance or a type of transport or add water washout facilities and recycling facilities, all of those things are done in an annual update, which is included in their subscription for an EPD tool. And there are multiple EPD tools available now to concrete producers. Once that setup process is complete, what does your EPD producer or manufacturer have to do to create a type 3 product specific EPD? Well, they enter the mix design, which is the pounds of cement, the pounds of sand and gravel, and they usually add some chemicals to make the concrete set faster or slower, or get rid of air bubbles and things like that. They push a button and they're able to look at what we call the nutrition label that Anik also showed you, which shows the summary of the EPD and the environmental impacts, not only carbon, but all the other impacts. And if they think that looks right, they can push another button and generate a type 3 EPD in minutes, which is downloaded to their system. If not, they can go back and tweak the mix design until they're happy with it. And of course, they're designing the mix not only to meet carbon and environmental requirements, but it has to meet certain strength, workability, and durability requirements so that the building will stand up and last the 100 years or so it's going to be designed to last. So that's the working elements of an EPD generator. And we've talked a little bit about this, but why EPD generators? Most importantly, they make EPDs cost-effective and accessible even to the fairly small producer. I mean, we're talking about $5,000 or so. So to get started and then be able to instantly generate EPDs. It also allows them to accelerate innovation and reduce carbon or other environmental impacts, but in concrete, it's mostly about carbon. And of course, this system is fully LEED compliant. So if you're doing a large residential complex, there's probably going to be multiple mixed designs, or one for a slab, maybe the walls might be concrete, there might be some columns, and the concrete producer can produce an EPD for each one of those mixed designs, meaning you can get LEED credit for each one of them. So that's basically the reasons that EPD generators have become popular. It's been slow that we invented them back in 2013, but they're now very popular and being adopted across the country and actually around the world as well. So how do you know you've reduced your carbon? That used to be a little bit tricky, but the General Services Administration of the US government has implemented a pilot program under the Inflation Reduction Act, where they've characterized concrete mixes over here on the left by strength class. So a 3,000 PSI concrete is probably for a sidewalk or something like that, and 4,000 or 5,000 PSI mixes are for concrete slabs, and then we get up into the 7,000 and above is usually for columns or post-tension walls and things. And they've identified what they call the top 20, I call it the best, the top 40%, and better than average. And for every one of these classes of concrete, so if your 3,000 PSI mix has a global warming potential or a carbon footprint of 257 kilograms per CO2 per cubic meter, you're going to be in the top 20%. And I've given a sense over here of the reduction, but these are actually low estimates because better than average, they're better than average limit. I just calculated the difference between the top 20 and the better than average. You can see you get roughly a 20% reduction, but better than average is also roughly a 15 to 20% reduction over the industry or regional average in your area. That data is available from the National Ready Mix Concrete Association, and that gives you, so you're probably looking at about a 40% reduction, fairly easy. And the big producers that are working on this, these low carbon mixes, can easily reach the top 20% when we're finding. And I suspect GSA is going to tighten down these standards as the Inflation Reduction Act is fully implemented. So I also wanted to give just a few minutes a view of where you can get these EPDs. So two ways. You can get a sense from this map where you can see that in California, there's about 152 producers, local plants that have EPDs. Over in Pennsylvania, we've only got about 10. Virginia has 23. But you can also go to our website, climateearth.com, and go to the subsection called AEC Resources up at the top, locate a material supplier and do a zip code search. And there's about 1,000 of these concrete producers around the country that have EPDs available in minutes. And of course, I also showed you the process and the cost because it's because of the Inflation Reduction Act. Practically every single concrete producer in the country is planning on getting EPDs, and if you show up with a project, they're likely to accelerate that effort and set up an EPD generator. That process takes about 90 to 120 days. That initial process I showed you where they go through the LCA process and get their system verified. But after that, they're ready to go and they can generate an EPD for your project for this specific mix you want for your job that meets all the constructability requirements, the workability, durability, and strength. And let's see. It was fairly short. I think Anik wanted to provide the primary educational portion of this webinar, but I want to emphasize that every home can reduce embodied carbon just by focusing on concrete. You can also get EPDs for some of those other materials, but they're not as common yet as they are for concrete, and concrete is a highly leveraged material using embodied carbon. And the way to do that is to require mixes that meet the GSA benchmark standard, and make sure that your provider of concrete knows that it's a purchase metric, that you're going to look not only at price and service and the other factors, but you're going to look at the carbon impact of the mix they submit to you as part of your decision process. And that along with, of course, you must meet the constructability requirements, is going to encourage them to have EPDs. So it's really a double-edged sword is a terrible word, but sounds sort of combative. But EPDs are on the rise, and you can reduce your carbon right away, but also you can encourage producers and manufacturers to get their EPDs as quickly as possible by presenting them with a requirement. So thanks very much. I will turn the back to our host, Brett, and I think we'll be opening up for questions. Thanks a lot.
Hey, everyone. Yeah, and I know, Anik, you've got a short time here, but then we're going to continue on with some additional questions. So I just want to get those over to you. And so since we have you here on the spot, and I know this is something you and I were briefly talking about, and then I know it didn't pan out, but it's still a good question. And that is, in the mechanical HVAC industry, I know typically sometimes they're even left out of these embodied carbon calculations in general, just because it's so hard to get data on them. So I guess I'm curious what you're seeing out there. If you're seeing, you said you're doing solar, very interesting. I kind of put that in the same class a little bit of appliances, maybe in mechanical systems. What are you seeing out there in the HVAC and mechanical side?
Yeah, so it's actually interesting because ASHRAE just had like a call for more research on LCA for HVAC system. And I think they are different than solar, because solar, I see it's more like a product you choose, and like you can take out the operation phase of it. For HVAC, it's different. It's really how much energy consumption. So the use phase is a lot more important for an HVAC system than the like making of the equipment itself. Like it's, well, I don't want to undermine like what people do in HVAC, but it's mostly metal and a mechanical system. So it's mostly the use phase that has the most impact. So it is kind of difficult to do that in LCA, because you need to have information about the building itself and how it will perform. So if you want to do like an EPD on an HVAC system, you need to make assumption about how it's going to be used. So like more traditional EPD, like if I do a solar panel EPD, I stop at, well, the solar module is outside the factory. It doesn't matter like how do I install it on the roof or on the building itself. So that's the main difference. So any product where most of the impact is during the use phase, you need to make some assumption about how it's going to be used. And then if you're not in that location, or your building is really different than the standard model, then you're not going to get kind of the saving. It could perform differently.
Okay. And briefly, the last question before to let you go, I think of the university infrastructure we have out there and what you're doing. Is that something then that maybe manufacturers who want to get into this, dip their toe in this, can work with students and do it through a sort of maybe internship or through a collaboration with a college and university?
Yeah, and there's more and more companies that come up to me or either want to know like or advertise some of those positions, because I teach a class on lifecycle assessment, for example, and so students want to know like what kind of company hire for those kind of positions, but the other way around too, like there's a need for industry for people that come out of college that know how to do those lifecycle assessment, but you also need to do a good EPD. You need to know like a specific sector. So and it takes some time to kind of know like how things are done and be able to identify like what information you need to be able to do that. But there's more and more people. It is sustainability and life cycle thinking is becoming more part of the curriculum in engineering. So it is required as part of, like, when we design product, we need to think about the full life cycle of the product itself, not just something. So I think there will be more graduate and more people trained in doing that. But it goes the other way around too. Like, until there is demand for EPD certified product, like Chris, you just show a map. Like, some states have a lot of them. It really depends on like what states require them or not. So there needs to be like a demand for it before. I'm not just going to graduate students if there's no job in that area. So there's need to be, it will follow as there is more and more requirement for EPDs and certification.
I think one of our members from Michigan pointed out we had none. Neither did our friends down in Indiana.
Yeah, I
So
saw that.
we were all very sad here in the Midwest, and we got to do better, I guess. So we got to get to work.
Yeah,
So.
and we have concrete producers, so that's not because we don't have any.
Right.
So.
Yeah. Well, Nick, I know you have to get going, and I know we're officially at our time too. So I want to say I thank you and Michigan State University for your time and doing this. And so thank you so much. And otherwise, we're going to stick around otherwise to keep answering a few more questions for those who want to stay on. So thank you.
Thank you.
And I know one of them that came up was just about how we're using these EPD generators for innovation. And I know the question on my mind is, are we, people are talking about carbon negative, right, cement. Are you seeing those kinds of things come through? Can the EPD generators handle that? Is that even real?
The word carbon negative is controversial.
Right.
I can actually see the questions, which is, how do generators assist in innovation?
Right, and I just wanted to add to that question. So yeah, thank you.
And also the generators that we support can support any material anytime. We also do what I call custom EPDs for innovative material makers. For example, we've just completed an EPD. This is the paper-based EPD that lasts for 5 years for a company called Urban Mining in New York. Actually, I think they're in Connecticut. And they take the New York City waste stream, pull out all the glass, and grind that glass into a powder which can be mixed and used as what's called a supplementary cementitious material. Mm-hmm. So a customer that has an EPD generator, we can drop the impact of that ground glass pozzolan, what it's called, into the generator database, and they can start generating EPDs right away using this low carbon material that's a waste product. And so the generator doesn't accelerate innovation per se, mm-hmm. but the database approach allows the producer to show the benefits of low carbon virtually right away. And so in that way, it's because a generator is just a measurement tool. It's right. We can't tell a producer to go innovate, but if they're going to innovate, they want to see the results and show those to their customers, and the generators allow them to show the results really quickly. Mm-hmm. You also asked about zero carbon cement,
right? Which is innovative, right? It's in theory supposed to be innovative. Yep.
Now, there are multiple companies out there trying to make new types of cement. The normal cement used around the world is called Portland cement. And that's the stuff that is really high carbon. For making a ton of Portland cement, creates roughly a ton of CO2, which is a lot. Imagine that's a ton of air, is a lot of air. Yeah. In these new cement companies, one of them called Forterra is pulling the CO2 out of the smokestack that's in a traditional cement plant, using that CO2 as a material to make a different kind of cement. That's a little bit of an oversimplification, but it's basically sequestering the carbon and using carbon as a material rather than as a waste product or an emission. Another company called Sublime Systems is using electrical energy, which could be clean power, to create cement. So it's rather than a giant kiln that cooks all that cement, and using different techniques, different chemical reactions as well. So getting close to zero is possible. A lot of the talk about zero now is, by purchasing carbon offsets, and these are different mechanisms. They're not hard measurements like life cycle assessment. They are financial transactions. You're essentially buying a credit from somebody who's doing something that they otherwise wouldn't do without getting paid for it. So it's a complex transaction.
The other question that I had that jumped out to me in a comment you made, you said something about stick-built homes and how the traditional concrete, cement, and forgive me, I'm the individual who swaps the two all the time, but when you're using that in a home, as we've seen, all the studies show that is a high component, but a lot of multifamily and commercial buildings are just loaded with this stuff all the way up. So wouldn't it be fair to say that it's even worse in the commercial sector?
Oh yeah, much worse.
Yeah.
What I said, you might have misheard me, is
Okay.
then in a standard single family home, you pour a little foundation, maybe for a slab, and then you build the rest of the home out of wood. So
Right.
but in a commercial or a larger residential, even a 4-story apartment building, you're going to approach 40% with concrete. I mean, you have a bigger foundation, you have a lot more structural elements, especially if it's a concrete core. If it's a steel core, you're going to have the same issue. But the impact is going to be in the steel and the concrete. And
Okay.
steel is much tougher to get carbon reductions for. I mean, the technology, you can't use melted cars for I-beams, but you can use melted cars for rebar in concrete, which is a little more carbon efficient than virgin steel.
Okay. I think about the part 2, option 2, the lead multi-attribute, and I think about, where that's looking at things that are beyond just embodied carbon, and going into many other various impacts of the environment. But in regards to, the industry that you're working in with cement and everything, I mean, how much do those other impacts even really show up as a result and need to be tracked and improved beyond emissions? Is that something that depends on the mix of the concrete?
No, it depends on the location of the concrete plant.
Okay.
The one other environmental impact that's fairly significant in concrete can be the water usage. And in states like California, actually in the last year or two, tracking water has become less interesting. The focus has shifted nationally and internationally to carbon.
Right.
But in states that have water shortages like California, the water can be an issue, and a lot of the concrete manufacturers in California do put in water recycling facilities where they clean and filter the water and reuse it. And they use a lot of water to clean the trucks and things like that, not only just to pour the water into the concrete itself. But otherwise, other impacts are fairly negligible in concrete.
Right. So those other items are not showing up, and it's the water use at the plant. And on the note of the plant, that's a good segue to the other question that I had. And someone again pointed out from Michigan, there's a lot of Michigan folks who are here, that on your map anyway, you showed 0. And so the question, of course, is there something to help you make a decision of sourcing locally, which we always recommend, versus sourcing from a plant maybe further away, but that has less impact? I mean, I guess in the case of the impact here, we're talking about CO2 emissions. There's going to be trade-offs, I assume, if you're porting in something from much further away for that transportation energy. How does that come into play, or how do you answer a question like that?
So concrete is fundamentally a local product. In
Yeah.
fact, in the early days of LEED, concrete got lots of credit because it was always local.
Right. We
You,
still get that. Yeah. Yeah.
You can only drive a concrete truck so far before the concrete in the back of the truck starts to harden
Yeah.
up.
Yeah.
Uh, uh, and relative to other impacts, so transport occurs upstream from the concrete plant and downstream. The upstream impacts are roughly 10 to 11% of the total carbon impact of a concrete mix. And it's very often very valuable for a concrete maker to import, for example, aggregate from a long way away. Example is, I'll use California again. The Los Angeles area in California has really bad, weak rock. And so if they import really good hard granite from British Columbia in a ship, in a barge all the way down the Pacific, they can use less cement in their mixes and have much reduced carbon. So local is not always a be all and end all. You have to look at all the trade-offs across the spectrum to decide what's best. And this is, I'm talking from a producer's perspective, because the buyer of concrete doesn't have a lot of flexibility. They really have to buy local.
Yeah. Well, this gets into another question that came up, and I want to kind of add to the context of it a little bit and keep on this thought first. And so there's some conversation in the chat and the Q&A about this sort of, maybe it's how do we convince these concrete suppliers to supply, get the EPDs to supply lower carbon. Someone's proposing an idea of a buyer's club, right? Like getting together and buying from further away, and filling all these projects. But I look at the International Living Future Institute, and one thing that the Living Building Challenge, and they've always had as a component of the requirement of their program, is an advocacy approach. And that advocacy, I remember when I was working on a living building project a long time ago, I was calling up manufacturers and telling them to declare their products, right? That was, I'm not talking about political advocacy here, which is part of their program, but I'm talking about advocacy to manufacturers. So I'm going to ask you a Living Building Challenge specific question next, but in the context of getting there, what role can people play, like here in Michigan, where we're devoid of this, apparently? What do we do? What do we say? Do we just need to get a lot of people to sign a letter and send it to the local manufacturers? Like, what have you seen to get people motivated?
This is a tacky answer, but money motivates.
Yeah.
And for example, I can assure you that Climate Earth gets a new customer every time Amazon builds a new warehouse, because Amazon, for better or for worse, mostly for better, insists on having EPDs for all the concrete that goes into their warehouses and their data centers. And they're looking at the numbers, and they're going to buy the concrete from the producer with the lowest carbon impact. We see that from other companies, same with Google, so the tech companies are having a lot of impact. And the last thing that's now enormous is the Inflation Reduction Act. The Inflation Reduction Act was passed last year. It's being implemented, and it's going to require for all government buildings, GSA's already started to implement, EPDs for 5 core materials, and that's going to be concrete, steel, glass, and I forget the last one. I think it might be fiber insulation. And the government, GSA is the largest building owner in the country by far. Yeah. And every project they have is going to require carbon. In fact, They're building a building right now in North Dakota, which also doesn't have EPDs, but the 3 local producers that are going to serve that job are out getting EPDs right now.
Great. I think that'll make a huge impact. And kind of continuing on, we were talking earlier, a question came up about the declare label, and I see I can go in and look at all the divisions available for products that are being declared for Living Building Challenge. Are you familiar with that? And do you know if that covers the base for general EPDs and LEED or what are your thoughts on that?
In construction, to understand the breadth of EPDs, we go to the database I probably should have talked about called EC3
Oh,
at
yeah.
buildingtransparency.org. It's also a great tool for anybody still on the call. They can enter a project into Building Transparency. They can enter all their materials, and they can start to look not only at the raw materials, but at the whole project carbon footprint. The most common EPD they have is concrete EPDs. That's partly because of the automation that's been made available, and that the concrete industry, by and large, has completely flipped from being highly defensive about being the bad guys to being focusing on innovation and how do we make concrete be a lower carbon. I've talked to many of the senior corporate people at the big producers, and some of you on the call may be surprised, but they are actually really dedicated to reducing the carbon of their material. They think it's a business imperative now, and they're investing money. They're investing in projects. They're investing in people and innovation centers. It's actually quite impressive. It just should go faster if you have a green head at all. But they're moving as fast as they can in most cases.
Yeah, and I'm glad you mentioned EC3. We had them on quite a while ago, and I probably should have them back to get an update. And they're also listed on our embodied carbon playlist channel. So I'm posting a link to that so you all can go and see some of the other sessions we've done. Well, right now, if you have, do you have a second for another question before we wrap up, Chris?
Yeah, I have 5 more minutes, and then
okay.
I do have.
Yeah, I have one of our members is requesting to verbally speak his question real quick, so I am unmuting him, and I wanted to give him a chance to ask here if he wants to chime in. There you go.
Is that me, Brett?
Yep. Hi, Hamad.
Yes. Good afternoon to everybody. We are at night here. My question is because we are heavily dependent on concrete buildings. We don't use wood per se. Is this embedding the EPDs, in the process, will impact the production because we massively using the concrete, and we are so keen, to reduce emission. I believe by 2060, 2060, we will be zero emission country.
And what country are you in? I didn't see that.
In Saudi Arabia, we're having the Vision 2030, which we are so keen, to reduce emission, including fuel and etc. But in 2060, we'll be a zero based country. So will that impact the production?
The simple answer is absolutely not. None at all. The only tiny impact you'd have wouldn't have any impact on your plant. But when we're collecting data from you about your suppliers and your raw materials and your energy consumption, one of your technical people, usually a quality control manager in the concrete industry, has to spend time with us every week, for a number of weeks, usually 4 to 8 weeks, so that we get all the data. It doesn't turn off your plant, but it takes some time from one of your critical technical people. And I think Saudi Arabia will be using the ISO standard. We have a different standard in Europe, but I've talked to some people in the Middle East, and I think they're gravitating towards the ISO standard, the same standard we use here in North America.
All right. Well,
okay. Thank you. Thank you.
Thank you, Ahmad. Well, Chris, we're going to wrap up, and I appreciate your time. For those of you who can't see, we've got Anik's contact information on the slide, hopefully too. Otherwise, we'll send that out if you want to contact her. So we appreciate her and MSU. And Chris, just remind us, where can people go to contact you or learn more about Climate Earth if they want to reach out?
For a strange reason, I didn't put my email. My email is probably the best way. It's Chris, CHRIS, is spelled on the slide you can see, at climateearth.com. Climate Earth is 2 words run together. And feel free to contact me anytime. I can also be reached at 415-391-2725. That's the phone number, 415-391-2725.
All right. Well, thank you all for attending and joining us here today. Thank you so much, Chris and Climate Earth, for spending some time. I really appreciate it and helping us understand this important information. So take care, be safe, be well, everyone. We'll catch you in March next week for our next session. So goodbye.
All right. Bye.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.